Lesson 90, Video Part 1. Alright, so please get out your workbook to Lesson 90 and find Part 1. Lesson 90, Workbook Part 1. We're going to start off with what you'll see there are some multiplication fractions. You're going to write the answers to each problem and complete the statement to show if the fraction you end with is more or less than the fraction you start with. So for problem A, you have 4 over 1 times 5/6 equals blank. And then it says 4 over 1, and then you have some boxes. We'll put boxes in these missing spots. So you need to fill out these 3 things. So read problem A. Problem A should be read as 4 over 1 times 5/6. What fraction are you multiplying by? You are multiplying by the fraction 5/6. Is 5/6 more than 1 or less than 1 whole? It's less than 1 whole because it's 5 out of 6, not 6 out of 6 or 7 out of 6. It's 5 out of 6, so it's less than 1 whole. So you will end with a fraction that is, will you end with a fraction that is more or less than 4 over 1? So now we know that this is less than 1 whole. So when we get our answer after we multiply, are we going to get an answer that is bigger or less than this fraction? Think about it. It's going to be less than 4 over 1. How do we know that? Because of what we're multiplying by. Whatever you're multiplying by will determine if it's more or less than than your first number. Because since this is less than 1, your answer is going to be less than 1. So, let's solve it. You will have 20 over 6. 4 times 5 is 20, 1 times 6 is 6. So, because we know that this means that the answer is going to be less than this one, we know that this number is going to be greater. So in there you're going to go like this, and here you write the answer down here. Just like so. So, let's move on to problem B. You have 7/5 times 10/9. So 7/5 times 10/9. What fraction are you multiplying by? You're multiplying by the fraction 10/9. And is 10/9 more than 1 or less than 1? It's 10/9 is more than 1. It's a top-heavy fraction. So we know that there's more than 1 whole in there. So what does that tell us about our answer? It tells us that our answer is going to be more than 7/5. So let's work this top piece of the fraction or of the equation. 7 times 10, 70. 5 times 9, 45. So you write this here. And what do we know about the fraction? What does this tell us? That it's more than 1, more than what we started with. So this fraction is bigger. I'll do one more with you. Problem C. Pause the video now, work the problem, and resume when you're ready to check your work. All right, so let's first work our problem. 3 times 5 is 15. 8 times 4 is 32. So what do we know about what we're multiplying by? we know that it's a fraction that is top-heavy, meaning it's more than 1. So we know our answer is going to be greater than what we started with. So we know that 15/32 is greater than 3/8 because the fraction we're multiplying by, in that parentheses, is more than 1. I'm going to have you do problem D on your own. Here's the answer to problem D. This is what you should have, that it's greater. I'm only going to put this up here because you should do the rest of the work on your own. All right, so we're going to switch gears into something new. This is called balance beams. Now, keyword in there, balance. You need to have balance. Here's 3 different balances. So I'm going to draw 3 triangles here. This is our balance scale. Each of these triangles, I'll fill it in, has a weight on them. So, these diagrams show balance beams. If there's a weight on only one side, that side goes down. This one, is the weight on the right or the left side? The weight is on the left side, making the left side go down. Second balance beam, is the weight on the left or the right side? The weight is on the right side of the balance beam, making the right side go down. Now look at balance beam 3. There are no weights, meaning neither side has gone down. It's staying up. It's balanced. So, here's a rule about balance beams. We figure out the distance of weights from 0 on the balance beam. In here, in the center, so this balance beam, the center represents 0. Going out, you have 1, 2, 3, 1, 2, 3. Going out from each distance. So, we figure out the distance of weights from 0 on the balance beam. If the distance is the same on both sides, the beam will balance. That's why this one is balanced, because we don't have anything on either side. The balance is at 0. So, I'm going to quickly draw a balance beam for us. So on the balance beam, it's going to go out to 10 on each side. Here's 10 on each end. 10 on each end, it's going to go down 7, 6, 5, 4, 3, 2, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, here you have your left side and your right side. The arrows, so here and here, do a block here on 7 and a block here on 5. So this block is on 7, this block is on 5. The arrows show the distance of the weights from 0. This arrow shows the distance to 5. This arrow shows the distance to 7. So what's the distance for this weight? The distance for this weight is 5. And what's the distance for the right-hand side? The right-hand side has a distance of 7. So, are the distances the same? No, the distances are not the same. So, will the beam balance? No, because one side is farther out than the other. The weight that is farther from 0 will go down. Is that the weight on the left side or the right side of this? It's on the right side. 7 is farther away from 0 than 5 is. So that means our balance beam is going to go like this. Because we have 5 and then we have 7. Now here's another example. Let me check to make sure this is visible. Yep. So, next one. We're going to have a block on 8 on the left side and a block on 8 on the right side. The arrows, again, show our distance to each. So, here are new weights. What's the distance for this weight? 8. What is the distance for the right side? 8. So, are the distances the same? Yes, the distances are both 8 on each side. So will the beam balance? Yes, the beam is going to stay balanced because it's equal on both sides. Both are the same distance away from 0, the center on each side, the left and the right side. So, I'm going to draw a new one of these. I'm going to make it a little bit bigger. Here's 0. 0 is always the center. Always going to be right there. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 on this side. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 on this side. Remember, this is left, this is right. So, I'm going to draw some new weights on here. Let's do blue again. I'm going to have a weight on 2. I'm going to have a weight on 4. And I'm going to have a weight on 5. I'm not going to draw anything on the other side. So, what's the distance of this weight? 5. What's the distance of this weight? 4. And what's the distance of this weight? 2. So the total distance on this left side of the scale is 5 plus 5 plus 4 plus 2. You add them all together. So, what's the total distance on the left side? The total distance on the left side of 5 plus 4 plus 2 is 11. The total distance on the left side is 11. So, what total distance do we need on the right side now to make this beam balanced? We need 11 on this side as well. Over here, we have 11 because 5 plus 4 plus 2. So we need it over here as well, on the right-hand side. All right, so I'm going to add a new weight. What is the weight I just added on the right side? 7. I added 7 to this side. So there is 11 on the left and and 7 on the right. Will the beam balance this way? No, because there's still more on the left-hand side. I have 11 over here and I only have 7 over here. I added more weight, but it's still not balanced. It's still going to weigh down on the left side. So, which side has the greater distance? The left side. There's more weight. So which side will go down? The left side will go down. Now, I'm going to add more weight to the right side. I'm going to put another weight on the 5 on the right-hand side. So now what do I have? I have 12 on the right-hand side. So over here I have 5 plus 4 plus 2 equals 11. And over here I have 5 plus 7, which equals 12. So, is the beam balanced? No. It's still not balanced. But which side has more? Which side is going to go down from too much weight? Or more weight, I should say. The right-hand side is going to go down because it actually has 1 pound, or whatever unit we're using, heavier. And it's going to make this side go down. So it'll look like this now. All right. All right, so now I'm going to do one more. I'm going to add another weight. I'm going to add a weight on 1. So I just did 11 now plus 1, which equals what? 12. So are my sides balanced now? Yes, my sides are balanced now because I have 12 on this side and 12 on this side now. I just added 1 more. And now they will stay balanced. Even though there's 4 weights on this and only 2 here, the weight of those weights is the same. So it'll stay balanced. Okay. Remember, if the total distance is the same on both sides, the beam will be balanced. Same, 12 and 12. All right, let's switch gears to mixed number operations. So, we have this equation right here. Read the problem. The problem should be read as 6 minus 4 and 1/8. 6 minus 6, right here, 6 minus 4 and 1/8. To work the problem, we have to rewrite the top number. The problem for the fraction is 0 minus 1/18, because we have nothing here for the fraction to subtract from. Can we work that problem? No, that's why we have to rewrite it. We can't do 0 minus 1/8. So, we rewrite the top number. We take 1 from 6 and rewrite it as a fraction. So I'm going to take 1 away and make this 5. I'm working with 8s here, so this fraction over here is going to become 8 over 8. Now I can work the fraction. What is 8 minus 1? 7. Denominator stays the same. And now I can work this. 5 minus 4, 1. What's my answer? Of 6 minus 4 and 1/8? 1 and 7/8. Remember, if the top number does not have a fraction, like this one, you rewrite the top number. So, open your textbook to lesson 90 and find part 1. Let's do the first one together. 9 minus 2 and 3/4. If you already know how to work this, pause the video now and work it and just check your answer. Because what we need to do, again, we're subtracting. I can't do 0 minus 3/4, so I need to borrow from my whole number. That turns into an 8. How do I know what my fraction has, what denominator to use? I look at the fraction below. I'm using fourths. So I'm going to have 4 over 4 here now. So what's 4 minus 3? 1. Denominator stays the same. 8 minus 2 is 6. What is 9 minus 2 and 3/4? 6 and 1/4. Problem B. 7 and 4/8 minus 3 and 5/8. All right. Here we have a fraction. However, it's too small still. I can't do 4 minus 5. I still need to borrow from my 7 to make it top heavy so I can subtract it from 5. So I still need to borrow, make that 6. So I'm adding 8, because it's my denominator, I'm adding 8 over 8 over here. What's 8 plus 4? 12. So this will become 12. Now I can work the problem. 12 minus 5, 12, 11, 10, 9, 8, 7, using my fingers. 7/8 and 6 minus 3 is 3. So what is 7 and 4/8 minus 3 and 5/8? 3 and 7/8. Problem C. We have 14 and 2/7 minus 2 and 5/7. So what do I need to do here? I need to borrow from 14 because I can't do 2 minus 5. I can't do a smaller number minus a big number. I need to borrow. So this is going to become 13 now. I'm taking out 1 whole, turning that into a fraction of 7/7, right? And I'm adding it to this. So what is 7 plus 2? 9. This now is a 9. Now I can work the problem. What's 9 minus 5? 4. Denominator always stays the same when you add or subtract a fraction. Now 13 minus 2, 11. So what's 14 and 2/7 minus 2 and 5/7? 11 and 4/7. The next one is 10 minus 3 and 2/5. I want you to work that one on your own. Because the answer, after you've worked it, and I should see it all written out on your work that I'm checking for, is 6 and 3/5. All right, so now please continue on to the next video for the rest of the lesson.